Uh, okay. Hello to everyone. Welcome. This is Ali Goharian, as you know. And as you know, this is our last season, and hopefully, its workshop was useful for you, and hopefully, it is useful and helpful for your scientific fires and for your future, for your scientific future. Actually, before starting, I wanna say something. Some tips actually. I wanna emphasize that this workshop is dedicating to present a workflow for designing kinetic adaptive facade based on energy view performance. Actually, it means our aims was not, for example, how we can develop dynamic adaptive facade according to morphology or according to geometry and configuration. We try to emphasize on developing an approach among 100 approach that are available in the scientific world related to dynamic adaptive facade. And this is, honestly speaking, this is very huge interdisciplinary study. And definitely it has a lot of aspects that you can approach to it. And definitely there is a huge studies about the dynamic adaptive facade. And we suppose that the level of this workshop is high, and based on the study, and to be honest, this workshop mostly is suitable for intermediate student and above. And as you can see, as you can saw in first session, we try to address some important gap or some important problems based simulation actually. And today we're gonna solve or we're gonna give a solution for that problem. For example, how we can determine the program as an annual schedule for making sensitive to sun position, or for example, if you want to make sensitive to occupant position, or both of them actually. And we will talk about this. Before that, actually, I prepared some investigation. Actually, these are gaps according to my recent studies and recent my investigation about the dynamic adaptive facade. As I told you, my test is directly related to dynamic adaptive facade to generating a framework. And I could actually provide some gaps, and you can screenshot from this because I know this is very important if you want to go to PhD, or if you want to do the high quality research. Actually, these are can be very useful and helpful for this. And as you can see, for example, we have a lot of gaps, and I tried to classify in some branch simulation based, performance based, morphology based, or energy based. But in this workshop, because we emphasize on simulation based, actually, I should say in simulation based, because of software, because of principle of software, for example, thermal issues entirely separated from daylight simulation. These two are differently entirely according to simulation techniques and simulation tools actually. And in thermal issues, estimating the energy load, such as cooling load, heating load, and something like this. We can have, for example, parametrical analysis or annual or periodic analysis. And I believe that many studies actually have been done. You can search on Google Scholar, and you can find a lot of study related to parametrical analysis, but it's a little bit far away from reality, because the dynamic in simulation is dynamic, but only for simulation you have to fix the one state of the dynamic adaptive facade, and as a result, this is not very right and correct output for estimating the dynamic adaptive facade. And also, we have non-parametric analysis. This is very important because both of them, your objective as a dynamic adaptive facade and sky must be dynamic. Actually, both of them must be dynamic in simulation to reach the correct to reach the correct output and the result. Actually, for example, EMS is a protocol. You can do such analysis, but it's only dedicated for unfortunately for conventional adaptive facade, and also you can control only EMS for conventional facades such as blind and well short, and you can control set point for edge. And in daylight simulation, actually, in recent months, as I told, a simulation workflow has been developed by Ladybug Tools team, and this is very important because you can simulate non-conventional facade dynamically, according to both, sky dynamic and dynamic object. Both of them can be combined and integrated, and you can harvest indices related to daylighting and daylight performance. But before starting however, in this workshop, we don't want to introduce such workflow, daylighting workflow. Actually, it will be for a future workshop. But before starting such daylighting simulation workflow, you have to need a schedule, annual schedule to how your adaptive facade must be moved, must move. And actually, it needs preparing a schedule, a program as an annual schedule. And in this workshop, we're gonna produce this. And as you can as we can remember, in first edition, we achieve that actually there is a lack of simulation for flow accuracy to extract the dynamic facade essay to reach a program a schedule concerning some position, actually, because some previous methods actually had a problem, had an issue, and they were not accurate as much as possible, as much as we want, actually. And we don't know how we could determine the best state in terms of indoor and outdoor condition for air travel. And definitely for this, the solution is optimization. In fact, we're gonna produce a schedule according to optimization for each hour during your desired period. For example, for me, the desired period is summertime. But for example, for your own project, it can be an annual schedule, actually. And the adaptability strategy actually is the action. It means that the facade can automatically adjust its feature and configuration characteristics or actions over the time. As and the classification of adaptability strategy include, for instance, seconds. According to time frame, it can be seconds. For example, facade may change configuration randomly in response to fluctuation light wind. However, this strategy, according to simulation, is very difficult and is very sophisticated. For example, most of the time you cannot make you cannot make sensitive your adaptive facade according to second. And also we have minutes, we have hours, we have diurnal, and we have seasonal. But actually, all of them needs to have a logic, needs to have a logic program for that. And another that is read actually in my thesis, actually I achieved this pattern, actually, namely local pattern, that it means a facade can efficiently to occupant's position or optimize environmental analysis. Actually, today we're gonna optimize the state concerning sun position according to environmental analysis. But there is a problem here, and when we are unfortunately dynamic adaptive facade has conflict with performances optimization. I mean, in general, optimization methods are used for static state, actually, especially related to building. I mean, when you want to refer to optimization operation for the building component, that you are dealing with the static components in building, and actually definitely it's conflict because dynamic adaptive facade constantly changes the state to optimize the indoor condition mostly. Fundamentally, dynamic facade actually is a optimization. Actually, is a approach can optimize your desired goals. Actually, that you determine for your project. As a result, the optimization is not compatible with logic of dynamic facade, but how we can use the optimization to dynamic facade. Definitely, it leads us to have produce a schedule and a program. And it's obvious facade adaptability annual program will be achieved after this operation. Actually, as I told you, producing such program for conventional adaptive facade it can be based on EMS or energy management system. And for non-conventional dynamic facade, actually, how we can produce the facade adaptability and program. And for this, optimizing the appropriate state hourly based to produce a program so that our adaptive facade can adjust itself efficiently. This phrase is very important for the researcher and for professional, especially for people who want to do the research. This phrase is a cutting edge actually approach in this field because I told you this is a part of my PhD thesis. And I know about its importance actually. And this is like our pattern, and we're gonna produce a program based on summertime, but it depends on you. It depends on your plan, actually. For example, you can produce according to your own project, own idea. And what is our solution? As you can see, let me to. Uh, as you can see, this is our plan. I mean, this is our space that I think has Zahra has been created according to radiance and thermal zone. Actually, it's our zone, and as you can see, some simulation workflow is grid based. Actually, and for example, for estimating and evaluating energy performance, actually it is not grid based. For example, it's local. You will be achieve output, but locally, zonally, not locally, and it's important. But for example, for daylight simulation, we have produce a grid as a test point or sensor, for example, and also for thermal comfort, you can do this, and you have to do this. You have to produce the grid base or test points or sensors. And actually, during we have to cut off the season. I mean, for example, summertime for this project, and in this summertime, we cut off the hours or our desired hours, as you can see. For example, 8 a.m. to 9 a.m. Can be cut through whole season, and the optimization principally can consider the sun position exactly as we wanted actually. And the simulation step by step actually will be done. For example, only for 8 and 9 a.m. The optimization will be done, and the schedule for this and in next step 10, 11, 12, 13, 14, 15 and 16 and 17 actually will be done according to optimization, and after that you can reach the best state for whole your desired period that you determined actually. And this is the Achieve Daily program for generalizing a seasonal schedule. For example, by optimization workflow, you could produce a schedule or a program how your adaptive dynamic facade must move according to concerning sun position. And
Annie, would be free that feel free to ask any question during your teaching or not.
Yes, participate. You mean participation from participation?
Yes. One of them asked a question. It is in chat box. If you would like, if you would like, I can read it.
Because I cannot see the chat box, but I try to chat.
Yes.
Sorry, could please let me? Could you please why you separate the hour? Yes, it's good question, I think. Because simulation must be considered this hour according to our desired goals. I mean sun position. For example, if you cut off this hour during your period, your desired period, simulation can consider and regard only the position of sun on that hour actually. And this is a good question, and the simulation principle is a reason for this actually. Okay, and please. My chat box actually has been no here. Okay. Okay, let's go to Grasshopper. Okay, guys, as you can see.
Excuse me, I disrupt you. All of you participants, could you please open your microphone if you have any question? Because
No, so this hour separation is like modeling our position. No, because no, actually, because we're gonna do the optimization. Uh, because we're gonna do the optimization, it is not like point in time. Maybe you mean, for example, we're gonna do the point in time workflow simulation, but not. It is annual simulation, but it will be cut off during among hours only based on our desired hours actually. You will see, no worries. And our modeling, as you can see, this is this algorithm is related to first region. We could develop this algorithm for our adaptive dynamic facade according to geometry, and this is radiance and energy plus zones that has been created by Zahra in previous season actually. And please let okay, and this is the recipe related to daylight simulation, this recipe. And view quality is another recipe for our goals. And these are actually our outputs as a criteria. And thermal comfort algorithm as well can another out criteria that that I will describe and explain about this. And please let me to mm, for optimization. For optimization, actually, I'm gonna determine the variables as a slider because variables and your objects are most crucial factor during optimization workflow. For this, only I decided to determine this variable. As you can see, for example, it can change adaptive facade in the horizontal direction, and actually it's imagination of some paths. And by this strategy, and according to cutoff hours during optimization process, you can find exactly sun position, optimal adaptive facade states concerning sun position by these variables. And another variable is the angle of edge triangle panel. As you can see, for simplifying is I decided to separate only in 10 steps, but it depends on you because maybe it will be very time consuming for optimization process. But it depends on your plan. You can divide your desired angle, but this is another variable as you can see. Uh, and in this algorithm, for daylighting, actually we have to run annual daylight. Please consider this because this is this is your question that you mentioned. This is annual recipe, and this is not point in time. And the view quality actually doesn't consider time, and only it considers obstacle geometry as an obstacle. And the thermal comfort is annual. However, I decided to change this algorithm because the PMV criteria as a thermal comfort a little bit was time consuming. I decided to change it a little bit, but there is no any difference. This is a PMV, another my criteria, and it depends on time. And after that we have to determine the hours that we mentioned. Actually I'm gonna determine the hours that I mentioned, for example 8 a.m. to 9 a.m. For this, I can use I can go to energy. Let me to I can go to Energy tab from Ladybug Tools, and there is a schedule here, and I can take the HP constant schedule. By this schedule, you can create the constant schedule. I mean, for total year that you want actually, and by the gene pool, I have to, according to this description, I have the 24 values input into these values input actually. And for this, I use the gene pool, and I have to input 24 hour and minimum 0 and maximum uh, must be 1, between 0 and 1 actually. You cannot increase the number because the schedule works based on 0 and 1, because the principle of this schedule based on fraction. And I can input the gene pools to it, and if I want to check this, I can, from Ladybug Tools, I can take LB hourly plot. Excuse me. First of all, I have to deconstruction data. No, excuse me. From a schedule, I have to HP schedule to data used for converting the schedule to data. Only this is for visualization. And if I check in Rhino Cross, I can see, let me to turn off this. As you can see, the annual schedule has been created, and I can produce a recipe for annual daylight simulation, both of them daylight simulation and thermal simulation. And if I turn on, for example, 8 a.m., you can see it will be shown on the chart, and the simulation only considered. I wanna simulation only considers this hour, and for example 9 hour. Actually, it's but this schedule for whole year, and I wanna make a cross-sectional study according to season. For this, only I have to, from the schedule tab, I have to HP seasonal schedule. I have to take these, and for this, I can input this schedule to this, and I need a base schedule, and this is not important. Only from HP search schedule, you can take one of them. For example, by list item, I can one schedule. I can select one schedule. For example, there is no any difference, and you can take it. And after that, I have to period according to my desired season. For this only, I can to take LB analysis period, and for example, from this to this, I think end mounts, start mounts, and end mounts. And if I want to check, I can check the dates. per period. Uh, for example, it starts from 1st June to 13th September. And if I enter this output to this, actually my seasonal schedule will be produced, and I can input this instead of that. And you can see this schedule according to seasonal, and our desired hour actually has been produced. And this is a good strategy. After that, for example, this schedule, for example, in daylight simulation, in daylight metrics component, we have an important input, as you can see, occupancy schedule, and by this schedule that you created, you can input to this, and okay, and I've forgotten the simulation is turned on. Okay, uh, after annual simulation in post processing, actually the occupancy schedule can be inputted to consider your desired hour. As a result, from this, your output will be achieved according to your desired hour that you determine specifically. I mean, from 8 a.m. to 9 a.m. And also the view quality as another our criteria, it doesn't need actually to have this schedule, because it doesn't depend on time, only depends on obstacle. And for another, I can input to thermal comfort recipe, and this is from output of PMV. I can input data, and after that, I can input my desired period, and it will be achieved. Excuse me, please. Let me do. No, excuse me. For this recipe, actually, it doesn't need to have determined the schedule, because actually it can cut the data from to whole data that actually is from PMV. For example, only I can carry it from this uh, from this uh, 8 hour and 9 hour, 9 hour. And only I can use this period output to this for evaluation of PMV according to my desired hours. Okay, and after that, in next step, we're gonna optimize this recipe. But before that, we have to explain about the optimization description and introduction. In the optimization process, this is an important thing here, that is formulating the design problem. This actually this action is one of the most crucial action during your optimization process. Because if you don't consider don't consider formulating design problems, you will be achieved outlandish answer or wrong solution for your optimization. Actually, for the formulating design problems, you have to introduce a problem statement for yourself, and you have to determine your dead-on information collection. For example, in simulation, dead-on information collection is from EPW, for example, and your geometry, for example, according to calculation of the software, can be achieved. And another is identification and definition of design variables. This is very, very important, and your design variable and your outputs in during the in the optimization operation has a main relationship, and you have to consider as much as possible, and you have to be careful, and you have to be very careful about the definition of design variable. And as you can see for this our project, only this slider, and this slider actually uh, has been considered depending on our variable, because completely they are related to daylight efficiency, thermal comfort, or view quality. Completely are different. If your variable actually has no any relationship with your output, your optimization process definitely will be wrong, and you will be achieve outlandish solution for your optimization process. Absolutely. And the formulating design problem is very important, and you have to consider. And also, if any people interested to optimization, this paper is very recommended, and it's a review of it's a review on simulation-based optimization methods applied to building performance analysis. You can read anything about optimization principle based on computation, actually, and this is very valuable. And according to this, in the optimization process, we have three major phases as follows: per processing, run optimization, and post processing. Yeah. In my opinion, actually, I believe that per processing is more crucial than optimization, computation, and optimization according to computation, and also post processing. As a result, one of the most important thing for processing the definition of your variables cautiously as much as possible, actually. And this is very important, and it is this slide has been created by me, and actually it shows about its importance formulating the design problems. As you can see, the computation only uh, I mean, designing variables actually is very important, and it depends on your knowledge. For example, you as an architect and designer, actually, you should have enough and sufficient knowledge about your problem, about your field. For example, when we are working on adaptive dynamic facade-based main performance environmental base, actually we have to study deeply about for example, thermal comfort, daylight, and energy issues. And the computation is not important as much as for example, design variables or objective. And objective is important, and it's completely on your the knowledge, because after that you have to interpret your outputs and your solution, and you have to make this decision, especially for multi-objective optimization. There is a main problem because decision making is very crucial for multi-objective optimization, and it completely depends on your knowledge and it depends on your study that you achieve. And okay, what is our formulating design problem? As you can see, we want to optimize. First of all, we want to optimize from 8 a.m. to 9 a.m. Concerning this test point, only this test point. But our objective or our criteria must be interpreted as we want, actually. For example, daylight efficiency should be a zonal criterion. If you want to make a sensitive or adaptive facade related to this point, actually for optimizing your adaptive facade, considering sun position, I mean, during this hour. Actually, this hour presents the sun position. By this strategy, you can present the sun position, but based
valid place to kick off your tour of the country. It's a tourist favorite, with many attractions to explore in these parts. The National Museum of Iran is one of the main attractions in the capital city and one you should prioritize on your bucket list of things to do here. This institution consists of two complexes, one for the Museum of Ancient Iran and the other for the Museum of Islamic Archaeology and Art. Of course, if you are a history buff, you will need no telling how inspiring a visit to the museum would be. The Sangan Waterfall, Sadabadad Complex, and the Grand Bazaar are other must-visit attractions in the city, but there are also others, such as the Milad Tower, Bird Garden, and the Tarbiat Bridge, to mention a few. Overall, you can rest assured of a fun-filled vacation in the capital of Tehran. Number 8, Persepolis. Talk about the most famous places in Iran, and Persepolis will always be in contention. Known as the ceremonial capital of the Achaemenid Empire, this ancient city is easily one of the top places to visit in Iran, and located in the plains of Marvdasht in the Fars province. This city has been ruled by many famous kings, including the great King Darius of the Persian Empire. Although the city is pretty much in ruins now, you'll still find structures that trace back to the once so great era. The various palaces in Persepolis rank among the top attractions in the city, and you will have a great time exploring them. You can also check out the tombs of the great kings that once ruled this great city on the site. The massive ruins of the gates of all nations, another significant landmark that is often used as a perfect background for pictures. No doubt you will fall in with this place when you arrive. Number 7, Shiraz. Iran is widely known for its quality literary and rich cultural history, and Shiraz is often referred to as Iran's cultural and literary capital. So if you are a fan of either, Shiraz is an undoubted place for you. Indeed, many great poets and literature legends have.
Okay, Zara, I'm coming back.
Okay.
Excuse me for this interruption because my internet connection actually
You're welcome.
disconnected, unfortunately. Okay, please let me share, and I'm so sorry, guys.
You cannot accept your apology. You cannot.
Okay, let's continue. Okay, guys, I was talking about formulating design problem. Concludely, we must consider all criteria in zonal or local state actually. View quality should be zonal criterion because it has conflict with the visual discomfort, and we have to make a zonal criterion for the view quality and visual discomfort because we want because we want regard this test point. Visual comfort should be a local criterion, and daylight efficiency should be a zonal criterion, and PMV because actually is exposed to direct sunbeams should be local criterion. I mean, the visual discomfort and PMV are completely related to each other, and it has conflict. There is a point in optimization. Consider the conflict. Actually, when your criteria has a lot of conflict, it definitely your optimization process will be correct after iteration and optimization operation. And for this, we okay. And as you can see, for daylight autonomy, please let me to visualize this. As you can see, we have produced test points for daylight simulation and thermal comfort simulation as follow. And its clear, it has been started from 0 to 41 grade base. And for 8 and 9 hour, actually, we considered number 8 as a sensor for this, but it depends on your project, your problem actually. It is my opinion. And actually, I decided to make sensitive the adaptive facade by this test point. But you can maybe for you it will be varied and various actually. And after that, we have all test point, and for daylight efficiency, I consider the average of daylight efficiency as follow. As you can see in this panel, this is my daylight efficiency, the daylight autonomy upper than 500 lux. And for UDI, because it must be local criterion, I decided to test number 8 as a sensor, and I selected by this list item component, and the output is here. And for the view quality, whole test point have been considered, and actually it has shown here. And for PMV, because uh, we're gonna to make it as a local criterion. This is a local criterion for only 8 test points, and all of them. As a result, these are my criteria or these are these are my fitness objectives for optimization process, and I have to put these. And these two are my variables. Okay, let's go to the optimization and how we can optimize by the velocity. And for this, I have to,
Excuse me.
but
This is like,
there's a
yeah, this is like.
question.
Yes, there's a question. And what do you mean by local and zonal criteria? Please
Yes.
answer.
Local criteria, these are my test points. As it's clear, these are my test points. When I'm talking about the zonal criteria and I decided to determine DA as a zonal criteria, I have I have to regard all test points. By this purpose, actually, you can make a zonal criterion. But for UDI, as a visual discomfort, UDI upper than 3000 lux, as it mentioned here, I use I use only number 8 test point. This is 9 and this is 8. And by this strategy, I can consider this metric as a local criterion. I think it's very obvious and everything is clear according to making zonal and local criterion. But if you want to have more information, you can refer to papers and you can read this. And okay, after that, we want to introduce the optimization. Actually, today we're gonna optimize by Velocity. This is one of most important plugin for optimization among Grasshopper plugins. If you are professional, definitely you have heard about the Velocity. We have a lot of plugins, and actually, this is one of the most powerful plugin for optimizing your any objectives that are available in Grasshopper environment. And this is actually it's based on genetic algorithm. The genetic algorithm is a very famous for finding the solution. And in computer science and operations research, a generation algorithm is a meta heuristic inspired by the process of natural selection. This is very obvious. It's based on Darwin principle, and actually it's inspired by natural selection. And this is it includes evolutionary algorithms, and you can achieve high quality selection by this algorithm. And here, according to mentioned paper, actually, this is some reason for why genetic algorithm is very popular among building performance simulation communities. And this is a very good graph, and you can see, for example, genetic algorithm in comparison with other optimization algorithm, how much is important rather than other algorithm. And this algorithm actually is work on based actually it works based on natural selection or Darwin principle. And in computer science description, actually, the initial population actually will be produced, and after that, if it is a fitness solution, it will be it will be exit from the loop. If not, the select parents actually will be occurred in this stage, and after that breeding or crossover will be happened to find the best children. And there is a good action, namely mutation, and by the mutation, the children actually will be changed a little bit to find the best solution. And this cycle actually will be repeated many times, but in computation workflow, you can determine, for example, how many loop will be occurred for the optimization process. And this is not important. The same actually. I think. Please let me. And the Walasi has been developed by Muhammad Maki, Milad Shokat Bakhsh, and Yeta Strong. And actually, it's very valuable optimization. As you can see, for example, in 2023, I tried to conduct a high quality paper related to a central light valve combining manual and NSGA2 algorithm optimization. And this paper actually is done by Walasi. And one of the most important thing for this paper is using the Walasi because its work was very wonderful, and we could find the best solution with high quality accuracy actually. And this is it is very highly recommended if you want to do the research, especially, or if you want to do any operation in the building fires. It's very valuable. And this algorithm actually has been developed by NSGA2 algorithm. This algorithm is one of the most famous algorithm among evolutionary algorithm, and actually it's a non-dominated sorting genetic algorithm. This name. And if you want to know about it, but this is not important for the designer and architect because it's completely related to computer scientists. And but if you are interested, you can study about that. And in the Walasi plugin, fortunately, we have a perfect online website, offline website. And this is a website, and you can, for example, download video tutorial videos, or you can download the documentation for more information, for knowing more information, and it has also through. And there is a lot of videos if you want to be dominant completely for doing the optimization based on Walasi optimization. There is a lot of valuable videos, and they have been uploaded by this team. And also here there is a Walasi Premiere that you can download, and this document is very useful, and all information has been supplied in this document actually. And everything has been prepared here. And if you download and install the Walasi, it will be appeared on the tab, namely Walasi. And there is a lot of component, but only we will deal with Walasi X. And only by this. And another actually is related to analysis data that you want, but it depends on you. If you want to, for example, analyze or interpret the data in post-processing, you can refer to it. But for this workshop is not essential. And most of the time, I think is not essential. Maybe depending on your aims and your goal. And this component is very easy. Apparently, is very easy, and also Velocity has a wonderful user interface and has a powerful user interface. For example, in the Velocity component, we have genes input. We have four inputs consists of genes, objective, data, and phenotype. The genes is very obvious. For example, your variables as a slider or gene pool can be inputted into this genes actually, and any variables that you are as a slider you can input. As a result, the genes can get only the slider or number, and your objective the objective can get your criteria. For example, in this case we have view quality, visual comfort, daylight efficiency, and PMV as thermal comfort indices, and for example UDA, UDI, and quality of view and PMV can be consist of can be included uh, for your objectives. And data actually is any information that you want to keep after per processing, because maybe you forget some things about information of your model actually, and you can input anything, any information that you think you can input in this data. And phenotype can be included such as geometry, meshes, I don't know, BREFs, and anything. But there is a important point because maybe your project is heavy and maybe it will cause Rhino crash. You have to avoid input phenotype into the velocity before post processing. After optimization, you can input the phenotype into this plugin, and after that you can you can have decision making or according to some methodology, some methods that have been supplied in the velocity component. As a result, it's very important to avoid inputting phenotype before uh, optimization. After optimization, you can input. And also we have output here. You can get genomes, fitness values, data, and your phenotype. And it's very obvious. Anything that you have inputted in this part, you will be achieved in post processing. And okay, as a result, this is a velocity x, and this is my variable that I have inputted here. This is and my fitness objective, as you can see, these are it's shown by blue color, and data, for example, for avoiding forgotten, actually I have inputted these to the data for after operation, and the phenotype is here. The phenotype is my whole geometry. This is here, and actually I can input, but this is important before optimization. Uh, but please avoid input the geometry meshes or BREP to phenotype input. If you double click here, the interface will be apparent, appeared, and this is some important tabs. For example, the velocity setting is very important, and you have to set your recipe here. And here we have velocity analytic, and you can interpret your data, or you can analyze your data from the iterations. And the velocity section, this tab is very important. And by some method, actually, some methods you can make a decision for find your solution. Because in objective optimization, as I told, uh, decision making is very crucial and is very challenging, because there is no any specific strategy for selecting your best and your optimal solution. And this is very important. Okay, please let me to. Okay. Uh, for instance, I have prepared a simple example here. This is not related to our project. Only I wanna show you how does it work. I mean, policy. For example, I have some uh, variables here, and I have some. For example, I want to maximize this area, and I want to minimize the distance. I mean, this curve must be, for example, minimized. And after double click, I can, for example, I can, we have the population is very important. You have to determine, you have to determine the generation count and generation size. For example, we have uh, 15 generation, and in each generation we have 25 here individual as a solution. All population size actually here is 1,250, and these are some recipe, but it's recommended to stay in such a way. For example, for crossover, you can change the breeding, as I mentioned. But if you want to know about this, or for more information, you can refer to the papers. And mutation probability, it's vice versa related to cross over probability. And these are, you can determine by default. These are parameters, because it's recommended by Deb and and other computer scientists. And for example, the number of genes will be appeared here, or number of values actually will be here. It's the sum of your slider, and the number of fitness objective will be here, and also the size of the search space. And after that, you can start here, and you will but and the data have been we will have be appeared here, and the standard deviation graphs, and also here we have parallel coordinate plots, and here this is objective your objective space, and the optimization after this actually will be finished. And here, for example, current solution and generation has been written here, and the number of Pareto front solution is 13. If you want, I think we don't want to explain about Pareto front solution. This is very uh, this is not this is very important, but for this workshop is not important. But if you want to know about Pareto front workflow, you can refer to paper. In general, the optimization actually needs to have a lot of study about it. For example, in one session, actually, it is not enough to explain whole of optimization process and whole of algorithm principle, actually. And if you want, you can refer to the paper. After 1 month, you will be dominant on the optimization principle. But the workflow actually, it was okay. It was only for showing you, and I'm gonna stop here and go to our project. Uh, because this project is very time consuming, I decided to prepare already, and the policy able to save the information about previous operation, and by double click, you can uh, go to policy analytic, and you can draw your solution. As you can see, we have here uh, daylight autonomy upper than 500 logs, and the UDI as well, and fitness objective 3 actually is quality of view, and fitness objective 4 is PMV. And by this, you can double click here, and these are and it can be full screen. And for example, age curve represent the generation, number generation, and age point actually represents your solution or individuals. And here we have a standard deviation age curve. The blue curve actually depicts your latest generation during optimization operation, and the red is early solution in during the optimization process. And also you can interpret a standard deviation value trend line and mean value trend line. And it means, for example, by increasing the standard of trend line, you can figure out your optimization process is going to be correct. And in mean value trend line, conclusively, but by decreasing the curve, actually you can figure it out. Yeah, your performance of optimization is correct, and you can make yourself sure your optimization is correct. And here, for example, you can select your generation and select, you can call the generation number, and you can call select solution. And this is by fitness objective. For example, fitness objective 1 is daylight autonomy. I can input here, and I can select the rank. How many rank that I have? This is actually, it has been here 165. Actually, I have solution for this. And for example, if I input 0 and select this button, the Wallace can find the solution in lowest rank according to daylight autonomy. Or if you want to increase daylight autonomy as much as possible, I can input the latest number. The latest is not 165. You have to subtract one parameter from this, because in Python, actually, the number has been started from 0, not 1. And only I have to input 164 as the highest rank and select. And as you can see in daylight autonomy, it is the most, it is the highest rank solution according to daylight autonomy. And also in this solution, you can check other objective. For instance, UDI is here, and I believe that this solution is very good for our project and forward, because the state of UDI as a visual discomfort is minimized as much as possible, and fitness objective PMV that is going to be zero for reach the high comfort for human. It is minimized as much as possible, and quality of view is maximized in this solution. And I can figure out this solution is perfect and uh, is very appropriate. And you have to, for example, for PMV, this is number 4, fitness objective. And I can select, because if I want to select the best or most appropriate solution, I have to input 0, not 106, because I'm gonna to be near the 0 this PMV, because the 0 depicts the neutral condition for thermal situation. And I select, I can, for example, this, and for example, the information about our objective, for example, for PMB is 0.71, and another you can read. And policy selection is very important. And by draw parallel coordinate plot, you can plot all solution that you have in your optimization process. And here some valuable method. And by this selection, you can investigate about the solution, uh, repeat fitness value. For example, in a fitness objective 1, I can input the number here and run PCP analysis, and you can see here, for example, in this area, the most repetitive solution has been happened here. And for example, for 2, if I want, you can see the most repetitive solution has been here. It means in fitness objective that the variation is very little, and actually the variation in other fitness objective is very higher than this and by this another solution. This is not very important and useful, but two last method is very crucial. By the relative difference between fitness rank, you can select rank here. For example, if I input 104 as a highest rank, I can select the I can see the optimal solution here, because this is the fitness objective is a daylight efficiency, and I wanted to maximize this fitness objective as much as possible. For fitness objective 2, I want to minimize this, and 3, I want to maximize, and 4, I want to minimize this. And I can decide that this solution is the best solution for me. And actually, then the name of this solution is generation number 14 and individual number 3, as you determined here. But there is a important point here. Maybe your project, you cannot achieve such solution, such such appropriate solution, such optimal solution. If you cannot reach this, and most of the time you cannot, but in this project, actually, we can find the best solution because we could determine formulating the design problem casually and with high details actually, and we consider carefully the formulating design problem. As a result, you can see the best optimal solution. But if you cannot achieve such solution, you can input the zero for this method, and you can see the smooth curve. In principle of optimization, this solution is optimal solution because the optimization actually try to find the solution average between all fitness objectives. But in this project, actually, we could. And by this, actually, this is another method. For example, for all objective, it tries to find the lowest rank or lowest values for four fitness objective. Or if you input 164, the solution will be appeared by by highest values for each fitness objective, as you can see. And also we have unsupervised machine learning method, but I think this is not very useful, but maybe it depends on you. It will be useful for you for your own project. You can you can call the generation, and you can call, for example, the cluster here, and you can see here, as you can see, your solution. And after that, you have to make decision. For example, we have here actually here your solution according to unsupervised machine learning actually has been provided here, and you can. But decision making is very important. Honestly speaking, multi-objective is very important, and it depends on you. It depends on your logic. It depends on your goals to select which one. And after that, for example, I can select it and add to export list. And for example, in this here, I can, for example, select my desired solution for achieve my phenotypes as a final solution, as my final solution. And also there is a thing here, and Milad Shokatbakhsh told me about this. Milad is a developer of plugin. He told me about the important things. However, this plugin has been developed for many objective and many variable, but it's recommended to determine the limitation for fitness objective. For example, more than 4 or 5 fitness objective is not logical. You can do it, but your result definitely not definitely, but maybe will be wrong and will be outlandish. But it's recommended for variable. You can determine 10 variables, and for fitness objective, 4 or 5 fitness objective is suitable for the optimization by evolutionary algorithm, especially NSGA2 algorithm. However, we have NSGA3 algorithm, but this plugin doesn't support NSGA3, but we will hold a course about NSGA3 in future, definitely. Okay, after that, you can, if for example, Pareto France solution here, and these are black, green is Pareto front, and for example, you can select your solution and add it, for example. And after that, you can export them to achieve your configuration and this. Uh, but I think there is a problem here, and unfortunately, okay, by this component, however, it's wrong because I did something wrong. I think I inputted and my data actually has been missed, unfortunately. But by this data, Zahra, please remind me to record a video for this. This is a last step for the optimization, and we can record this process, and after that we can send to Telegram channel because the data has been missed. If I want to run it, maybe it will take a time around 13 minutes. But you can find your desired by this component. And for example, after this, we can find the best solution. If Zara, if we have time, we can run it, but maybe 50 minutes it will be taken. What do you think about it? Because I inputted.
I think your first suggestion is better than the last one, and because it takes a long time for this. The latest session. And yes, people, what's your idea? Could you please send it later? Yeah. Ghazala asked us that could you please send it later to Telegram group. And the
Yeah.
other, yes, we send it. We will send it. And another one asked that could you please explain what is the optimum solution and how it helps in designing the dynamic facade? Is one state of dynamic facade?
Yes, unfortunately, I have missed the data because I did something wrong actually. But we will record this. But the information is available. But 20 minutes it will be taken if I want to run again for the for this. It depends on you.
Okay, okay. We will send the video of this tutorial to them. Okay. And it is not necessary to teach something like this one and run it.
Please let me to finish the this. Okay. Uh, someone told, uh, as you told, this is the best solution. For example, and I can.
Excuse me.
What?
Could you please check the chat box for yourself?
I mean, just explain what is it. It is the just one state of the. Yes, actually, this is we tried to optimize the configuration of adaptive facade in determined time. I mean, between 8 and 9 hours. After this optimization, will be achieve one solution. We will be achieve one solution as a configuration, and it will be repeat. It will be repeat for example, 8, 10, 11, 12, 13, 14, 15, and 16, 17. After this, you will achieve 5 configuration, best configuration. For example, this is here. Please let me. Please let me. This is a good question. After reach the best solution. For example, this is a all optimization state and are available, and this is here. This is a best optimization between 8 and 9 a.m. and this is for 10 and 11. And if you check, this is the best this is the best design concerning sun position. And after that, this is a schedule, this is a program. And if you can see, for example, we named here now 8 and 9, namely A, and actually it depicts 1, 2, 3, 4, 5. And we have and actually I'm gonna create a schedule, a program as a schedule or as a adaptability strategy for my design. This is 1, 2, 8, and 9. This is actually will be switched in this essay for 2Ds, 3, 4, and 5. And as you can see here, we have produced a schedule. It is our schedule for our adaptive facade, but you can cut the whole schedule for the summertime. For example, your design actually will be operate as is follow. This is ASA, this is BSA, this is C, E, and D. And this is a schedule that we wanted to produce. And here there is an algorithm, but this algorithm is not related to this workshop. In future, maybe in Persian language, we will hold the course related to how we can simulate non-conventional adaptive facade based on both sky dynamic and object dynamic. And as you can see here, I conducted a paper, but it's under actually it's under review right now. It has not been published. It's related to this algorithm, and by this strategy, after publishing, you can read it. By this strategy, uh, is it's a little bit heavy. Actually, we decided to develop this adaptive facade, and we try to produce a schedule like this workshop. And after that, by this algorithm, you can input your best geometry that we optimized here. You can input here into this, and state will be fixed. And after that, your aperture actually will be provided. And model, it's very brief. I think it's very brief, and it needs to introduce uh, very much. And optimize and annual data simulation will be done. And after, we have a very important input dynamic schedule. And here we try to produce a dynamic schedule, and only I can uh, input this into dynamic schedule. And your simulation actually will be done in whole year, and your dynamic facade during the day actually will be moved in your desired design actually. But this recipe will hold a course according to this recipe, but a little bit is sophisticated according to understanding it, and maybe in future in Persian language we hold a course related to this recipe. It is very important, and we could actually write a professional paper, as you can see here. However, it has not been published, but it's very important. As you can see, for example, in conventional method for approaching the adaptive dynamic facade is a static workflow, and most of research, 90% of research actually has been done by this workflow. But for first time, we tried to we tried to analyze by dynamic workflow, and if I want to say briefly, multiple geometry actually will be produced, and multi-radiance modifier also and duplicated test point will be produced for this optimizer. It's very professional and it's very valuable, and actually it's cutting edge daylight simulation according to techniques and tools. And after that, you can harvest illuminance or any metrics that you want. And this paper actually like this workshop. And for example, here we try to determine the schedule like this workshop. And this figure actually uh, is according to this workshop. Actually, in this workshop, we try to produce this schedule for the moving our objects, I mean, our adaptive configuration, and we try to supply the annual we conducted here as appendix. As you can see, we try to three a schedule according to some logic. One of them is related to this workshop, and others is related to my opinion and another criteria. And this is the ray tracing. This is ray tracing based logic, and it's related to directly to this workshop. And hopefully, in future, you can read this paper. This is very valuable, and I recommend you to follow this paper. Okay, if there is any question, please. Thanks. So this dynamic facade that all essays are defined by us is not adaptive by sensor. Yes, definitely, because we don't want to control this dynamic facade, because there is no any possibility to set a set point for as a feedback for control your dynamic adaptive facade in radiance, especially. In, for example, conventional adaptive facade, yes, you can follow Amir Tabatkani documentation and you can read this. And however, recently he has succeeded to publish a paper for non-conventional adaptive facade, but this is not directly related to this simulation. And actually, they tried to gather some software and some coding for this, and actually I read it, but it was not very well clear for me. I don't, because maybe in methodology a little bit actually has not been explained according to software and plugin. But this actually the workflow for Radiance actually is this. And interesting thanks story, could you just explain more the dynamic schedule you connected to, you mean, I think you mean, hmm, you mean here, yeah? If I'm wrong, please tell me. You mean this component? Yeah. After producing the schedule or adaptability strategy, uh, I I inputted to this component. I inputted this component. Actually, this component will be done after post processing, not per processing. In your maybe it's a little bit misunderstanding because I didn't want to explain about it, but for your information, only for your information, your simulation will be done here. Your geometry actually will be supplied here and here, and model and annual daylight simulation will be occurred according to multiple test point, according to multiple geometry and multiple modifier. And after that, and after that, the result actually can input to this component. And by this schedule, you can comment how your adaptive facade must be moved, how your adaptive facade configuration must be changed. Actually, from this component, you can control how your adaptive facade during whole year, according to daily program, according to hour by hour, how it does work, and how must be changed according. And actually, it is your comment, but it needs to have a logic. And in this workshop, we try to extract this logic. And if you are doing the research, you know about its importance. This workflow is very important for professionals, not for beginner students, honestly. Yes. And what does mean this dynamic schedule? It's very obvious, I think. This is a schedule. This is a schedule. This is a schedule for whole year. We determined actually, for example, between 8 a.m. and 8 a.m., 8 and 9 a.m., your facade, your state of facade actually must be as follows. This is, for example. And for two, actually between 10 and 11, your facade must be changed according to configuration, according to this, according to this. For example, 8 and 8 to 9 a.m., this is 10 and 11, this is 12 and 13, this is 14 and 15, and this is 16 and 17. And actually, you have to, this is a little bit complicated, and maybe it will you distracted, unfortunately. But we can, for example, input here, and we can, excuse me, this is not modifier, this is geometry. You can, for example, input here. After that, you can input its name. We can determine for this, and this name actually will be produced as a schedule, and after post-processing will be inputted here, and your dynamic will be moved according to your desired schedule. And your facade actually will be moved as your desired schedule that you determine. Okay. Thank you for your participating, and thank you for your everything. Hopefully, this workshop is useful and helpful for your academic future. And if there is any question you can ask, and I can check my. And Zahra, if you have any opinion, you can reveal them right now.
Thank you. Please close your sharing.
Please let me. And please remind me to send this GH file to Telegram channel. And how we can stop my...
Stop sharing. A red toolbar on the top of your screen.
Please.
Thank you.
Okay, thank you. Okay, let's continue.
For joining us and being there till the end of the session. I actually hope this 4 days gets you the valuable and useful information to get familiar with this research area, and hope you enjoy this event. Actually, we hope this event will go on in this future with other professors. And please, we are open to get connected with each other, and also from LinkedIn and Telegram group. Take care. Thanks a lot. Have a nice day or have a nice night in order. And goodbye for now.
Have a great time, guys. See you. And if you want, you can collaborate in future with us and with Compu-lyzer team as well. Thank you for your
Yes, of course.
participating.
Yeah.